So a quick equation is that the sum of squares regression plus the sum of squared error is equal to the sum of squares total. So the sum of squares that can be explained by our regression model plus the sum of squares that can be explained, which is our error, should equal the sum of squares total. And that number SST is something we use to calculate R squared and R. So basically, this is just a quick little equation. Find SST, you just plug in 51 in here, 17 in here, and add them up, and you've got SST. What is that? 68. And then here it says, given SSE, SSR, and SST, find the variance in the dependent variable that can't be explained. So the sum of squared error is measuring how much can't be explained by our linear regression model. That's not a really strict mathematical explanation of what that means, but it gives you the right idea. Sum of squared error they calculated was 21. So the variance in the dependent model that can be explained by the variance in the independent variable, that's 21. If this said the variance in the dependent model that can be explained instead of can't, that'd be SSR. So SSE is what can't be explained, SSR is what can be explained. So what does the sum of squares of regression measure? So the reason why we're talking so much about these numbers is that sum of squares regression, sum of squares error, sum of squares total, these are all related to calculating the coefficient of determination and the correlation coefficient, which is just the square root of this number. These numbers help us tell how closely our data points follow, in this case, a linear relationship. How closely do they match a straight line? If it's really close, then R is going to be really close to 1 or to -1. If it's not a good fit for the data points, then R is going to be close to 0. Okay, so to calculate these values, we need SSR, SST, SSE. And the sum of squares regression part is measuring how much of the variation in the y values that is explained by the estimate of the regression equation. How much does the regression equation help us explain? Okay. SSE measures the variation in the observed y values that is not explained. This would be SSE here. And then the x variables, we usually place the x variable as the independent variable, so that's not what we're considering with these numbers. The y variable is the one we try to make the variable we're trying to predict.